I'll start with some presentation and and give the time for everybody, any late joiner, to not lose anything important. So good morning, good afternoon. I'm Daniele, and welcome to the Distributed Tracing and OpenTelemetry workshop by Amplication. So I'm myself, the host here, the speaker is Daniele Iasella. I'm a principal software engineer in Amplication, and open source SaaS backend development platform that will allow us developer, software engineers, or anyone interested in developing backend solution, backend APIs in Node.js to develop their application in a much faster way, consistent way, and a production-ready way. So pretty much saving a lot of time in our development cycle, avoiding to rewrite the same code that we usually write when we create new services. So today the agenda of this workshop is based on a few steps. The first one, we will have a problem statement. We're gonna see what problem we try to solve. We're gonna have a basic introduction to tracing, open and distributed tracing, then an introduction of OpenTelemetry and how does it play a role in distributed tracing topic. And then the juicy part is gonna be, we're gonna have an Handson or a virtual Handson. I'm gonna try something live. That, bear with me if anything goes wrong. That usually is what happens during lives. But I'm gonna try to I'm gonna try my best. So we're gonna investigate and play around with the data that we're gonna collect. And we will finally complete the workshop with some best practice, a couple of gotchas that we see, and a Q&A session. So feel free to ask any question you have in the Q&A dialogue that you see on Zoom, and we will answer as we go if we can. Otherwise, we will address them at the end. Yeah. Let's start in. So, problem statement. So, in 2023, well, it's been not just this year, but it's been the last few years, most of the companies and solutions move to a more distributed way, right? So we have multiple systems and applications running in different places, and they speak to each other. Up to till like the earlier generation, where we had a lot of monolithic application, logging was pretty easy, right? You have everything, all of your services were actually part of the same service, so it was just one, and the log was enough to investigate. And you also have instruments like APM, so application performance monitoring, to understand how your monolithic application was working. But now with like a more distributed system architecture, it's getting harder to monitor and correlate logs between different systems. In the image you can see on the screen, if you don't know what it is, it's pretty simple. It's the Uber's microservice architecture, roughly in the mid of 2018, right, just before pandemic. And that was an image taken from a tool that we're gonna play with later on. It's called Jagger, an open source tool. So out of that mess, how is it possible for us to understand if a single request made by a user or a set of requests made by a user flow into the system, right? And if something happens, how we can actually investigate it, how we can get the root cause and so on. Well, distributed tracing is actually the answer to that. So what is distributed tracing? Distributed tracing is an observability tool, let's say, and is a method actually to monitor requests. Right? Request the paths grows across different distributed environments, and all of them have a common unique identifier. Distributed tracing can be achieved in architectures that could be synchronous, like GRPC or REST or GraphQL, for example, or async patterns as well, like request reply, event sourcing, and pub/sub, right? So where and why do we need distributed tracing? Well, microservices and the complexity around microservice makes it quite difficult to know a specific request, right? The path that it goes through. And distributed tracing will act as your flashlight, right? It will shine the guiding light to the request, and you understand the flow across your system. It will allow you to optimize performance. It will, how does it do so? It will enable you with data to unveil latent bottleneck that you might have not noticed because in the logs or in the monitoring of single service were not visible, or those like bottleneck, or the timeout waterfall, for example, is one of the classic example where one of the basic service might be taking a bit longer. They will trigger a timeout, then a mid service that is calling it, that is triggering a timeout of a bigger, like a parent service that is calling the middle one, right? So it allows you to discover these kind of issues. It will allow you to detect and analyze the root cause of problems in a much faster way. You don't need to manually correlate logs, check which log is the starting, each error is the starting error of your flow of errors. You will detect straight away who is the cause of the initial error, and you can just focus on finding the solution of that application. It will allow you to act on scalability and load balancing. Since you have data about the flows of your requests across your system, it will let you make better decision, right? If you see that most of the requests goes, for example, in this diagram to the payment service, then and not that many to the notification service, you might make decisions on the infrastructure to give a bit more juice to the payment service, more instances, more resources, and a bit less on notification system, just to keep everything under a good money management group. It will allow you to have service dependency. You will be able to see service dependency without the need to manually maintain like a service registry, because it will show you a map in real time based on the actual request from the user. So again, all of these data that you get, as they say, data is knowledge, knowledge is power, is actually, this is a classic example, right? You go and collect a lot of data that will allow you to make better decisions. You will make informed choices where you want to refactor a service, replace a service, or just improve a service based on actual data without shooting in the dark. And final, and not least one, compliance and security. Security is a must in the current era. It's something that you can't just avoid, right? Well, distributed tracing will become your sentinel. It will allow you to spot any anomalies in the request, and ensure that you're always compliant with whatever compliance standards you want to be compliant to. So what is the distributed tracing? What is it made of? So we know that allow you to see through it. How does it do it? Well, it's made of, and it allows you to do that kind of investigation thanks to three components: a trace, that is a representation of the path of a single user request as it moves through various services, like service A, B, C, D, like in this case. And it is a collection of spawns, right? Each spawn is a representation of a single operation within one service. So it captures the information like start time, end time, duration, any additional metadata or annotation that might be useful to get more easier understanding of what is happening, right? And the last one, the context propagation. So in the way of how distributed tracing allow you to merge and mesh all of this information together is thanks to this context that gets propagated, and ideally is made by one or more unique identifier. We can call it, well, in this case on the diagram is unique ID, it can be a trace ID, and that trace ID will be flowing through, as a context will flow through the services, and each spawn will be able to attach, right, and store information against that trace ID. So we might have now a brief idea of what distributed tracing is. So how do we select the right distributed tracing, the right observability tool? Well, nowadays you want flexibility. Well, anybody, right? You want flexibility. Flexibility comes with needs potentially to be vendor agnostic as well, solution agnostic. And at the same time, you don't want to add more weight on the engineers to implement solutions, just to track that the solutions that actually make money for the company are running properly, right? So one of the requirements then is to have something that is kind of a funnel in, funnel out architecture for this instrumentation that will allow you to instrument every single one application that could be written in any language you want in a similar way. And that's it. Once that is done, the information will flow to one more or replace different visualization tool, different observability tools without the need of changing the application. And OpenTelemetry is where we actually play our decision to. So OpenTelemetry is an observability framework, is vendor agnostic, is tool agnostic, is open source, and is part of the Cloud Native Computing Foundation project. So pretty cool. So what is it made of? How is it that cool? And how does it work, right? Well, it's made of a lot of components. It has specification for all of these components. Is part of the OpenTelemetry framework. Standards protocol that define the shape of the telemetry data, defined again by the OpenTelemetry standard. Semantic convention to define standard naming schemes for the common telemetry data types. Again, APIs to define how to generate this telemetry data. A library ecosystem that consists of so many libraries that usually you could be enough to find a library that will fit with your programming language or your framework, right? Or your libraries. It's quite nice. And some automatic instrumentation components that will allow you to generate telemetry data without requiring any code change. Moreover, there is tools like the OpenTelemetry operator for Kubernetes, for example, if you use it. So that's still maintained by the OpenTelemetry organization. And last but not least, the OpenTelemetry collector that you see in the architecture diagram in the middle. So the OpenTelemetry collector is your glue, is what allows you to do this funnel in, funnel out architecture, and is a proxy that receives a lot of different inputs from different services. They will look like similar, right? Because the shape is actually defined by a semantic convention. It will process this trace data, telemetry data, not just traces, also metrics if you want. And it will export this telemetry data to a system that could be an open source solution like Jagger, Prometheus, or commercial offering like the AWS CloudWatch, AWS X-Ray, for example. So I've been rushing a lot because I like to give more attention to the hands-on, to have the proper look and feel of how this data is going to help us, right? So what we're going to do right now, I'm going to share my screen and we're going to try in real time to create a simple Node service. It's going to be just a JavaScript file with a request made with an HTTP client library called Axios. You probably have heard of it. Then we're going to create three services with Amplication platform. I'm going to create one courier gateway. There will be a service in charge of communicating with an hypothetical courier company API, set of APIs, like UPS or DHL. And we will have a service called shipping service that will be in charge of creating a new shipping, and it will call this courier gateway to get the prices. And we're going to fake a bit of data there as well. And we're going to also create, if we have the time, a notification service that will communicate with the shipping service through not direct REST API, so not synchronously, but it's going to happen asynchronously through Kafka. Only if we have the time. Let's see how it goes. And after we have all of this, we're going to add tracing to all of our services. And we're going to just analyze the data and play with that, see how data can help us and what data we actually can see. But before I start, I mentioned instrumentation. For people that are not familiar with the terms, instrumentation is the term that enables distributed tracing. So it involves adding code to log this data, right? The start, end times operation, as well as the trace ID, the spawn ID, and any additional annotation you want to add. Plus, when I speak about analyzing the data or trace visualization, if I mention that term, it's just the pure terminology to describe the action that we do when we open one of these tools, like Jagger, for example, and we visualize the actual trace data and see the entry point, the expiry point, and whatever is happening in the middle. So let's get some source code. So I'm gonna start from the application. So right now I've already created a repository. This will be available, that we will put in the chat links. This is an initial repository. There's nothing else in it. I have a Docker compose, a collector that we're gonna see in just a second, and some DB schema. Those are Prisma schema and ORM that I've been using, and I've been using with Amplication. And those are kind of schemas that were generated from a previous database that I had. Let's say that I had a database for the courier gateway, one for the notification, one for the shipping, and I don't want to rebuild it from scratch from Amplication. I just introspect this, and I will use this one to generate the application services, and we will go on from there. So let's go into Amplication. I've logged in. This is my project. You can see it's completely empty. I have 0 resources, and I already connected to my Git account, the GitHub account in this case, and to my repository, we just saw. So I'm going to create some services. So we say the courier service gateway is going to be using that repository. I want to use REST today, but I'm going to leave everything open because I want to see all of the files created, and I want the admin UI to potentially modify some data, and this will become really handy in a second. So it's going to set up as a monorepo setup using Postgres. I don't want anything. I want an empty template, and I want to have some authentication just for this service. Done. I need just to commit and the changes and build, and that will generate the code for me. But before doing so, I'm going to do a couple of additional things. I'm going to change the settings for my Postgres because I'm going to share the same Docker service for Postgres across all of my services. I don't want to have them to collide. So I'm going to call it, this is going to be the courier service, say, and I'm going to also import, as I said, my previously generated schema. This is going to generate all of the entities that I need. And if I go in entities now, you can see those are there. And nothing is stopping me to add additional information if you want to, but we don't want to waste time on that right now. So let's go and create the other 2 services that I mentioned before, the shipping service. I don't need the admin UI in this case because I'm not going to use the database. It's just to make it see that it's working. And I don't need any authentication. It's bad. Of course, in your production code, you will need authentication, but in this case, we are just demoing. And then we go again, we're going to import our schema. Really, really, one of the latest features we developed is really smooth. I love it. So quick. And we got it. Ready. We got mine. I'm going to replace again, as I said, for the other service, I'm going to change the name of my DB into shipping. I can type. Save. And I'm going to go for the last service, the notification service. Same thing that I've done for the shipping. I don't need an admin. I'm not really neither the REST APIs or the GraphQL APIs, but for the sake of the example, I will let it go through, and I will put no authentication. And just to have everything ready before we complete, again, last thing, I'm going to change the notification. Before we complete, let's also add the Kafka integration. So I'm going to create a message broker with some topics. I'm going to call it shipment.create shipping.v1 is going to be my topic. And I'm going to make the shipping service being using Kafka and being a sender, so a publisher of this service. And on the other side, I'm going to do notification service to be a subscriber, so receive. And in the plugin, again, I'm going to install Kafka. And I'm going to add my message and build. This will start the build process. This will generate the application, create a pull request that we're going to see in a second, and this is going to be pushed to our service. In the meantime, it will take a few seconds, but I don't want to waste time. So let's dive into what was already in that repository. I have created a Docker compose. As I said, I want to share the same database with all of my services. So I created this level, this Docker compose, but all of the services that application generates comes with a dev Docker compose that you can use to start really quickly. But this is for convenience. Then we're going to have the Jagger all-in-one. Jagger all-in-one is actually all-in-one. So in this case, we don't need to specify a collector gateway. I'm going to do so just to make it clear what the components are. But if you expose the ports for the receiver in the Jagger all-in-one, that will going to work. Then we have, in this case, a collector gateway, just because I want to specify some configuration, like in this case, and I want to expose GRPC receiver and HTTP. So this is the configuration file. Let's dive into it. Right, you might remember a second ago, we said there is made the OpenTelemetry collector is made of 3 main components alongside the others: receiver, processors, and exporters. Well, the receivers, as we see, we are just exposing the protocols and the port. Those are the default ones. So I would recommend to leave them as default if you're running locally, because it will be much easier with the library that we will see in a second. Processor will allow you to define how often the trace information will be processed. You can batch them together in batch of 1 second just to increase the performance of your system, and not by one. And you can also define custom attributes at this level. Like in this case, I'm inserting a test key with a test value. And that means that everything that this receiver and this processor actually will process will also add this key and value. So we will see those one later on. Those are important as this has a configuration that are quite handy if you have like a platform engineering team, so they can, let's say, develop like a run different OpenTelemetry collector, depending on the technology. Maybe you have one for Kubernetes. You can actually predefine attributes for your Kubernetes cluster to make it visible where they are coming from. And then finally, you have exporters. So I'm defining 3 exporters here because I want to show the funnel out architecture. So the first one will be a simple logging, and it's going to be in the collector console output. We're going to have Jagger. So it's going to use, as you can see, the other service in Docker. And the last one is going to be a commercial option that you might have, a Spectre. We're not going to see that one, but it's just to see that that is possible. This authorization code does not work, so if you are willing to use it. So, but this is kind of everything that we have. And then go back to the Docker, have like some other services for running Kafka locally as well. I'm going to just uncomment those and run all of this just to be ready. Okay. Done. We have everything started running. Let's go back to the system. So we should have all of the services generated. Yep, they are all there. Let's go into my account. I have a pull request. I'm not gonna review the pull request, of course, right now. You will, right? There are a lot of changes, but I'm gonna just trust it and we're gonna see it. So I'm gonna merge it into main. And now I'm gonna pull the changes. Of course, I need to undo my changes for just this pull it. I have now all of the applications. As you can see, I have an admin for the gateway. So let's run the commands that we need to run to make everything up and running, just really quickly, is in the README. We will need to npm install, generate the Prisma types, and run the init because the Docker is already running as a common Docker. Okay, I have created this run many little script, bash script, just to help me out because I don't want to type stuff over and over. But I'm gonna run, for example, the npm I install in each folder inside the apps that is not admin. In the meantime, on the side, I'm gonna run the npm install for this one. And as this make install all of the dependencies, what we're gonna do, we're gonna update the environment variables, because once we start serving the services, they will all default to 3000 and they will clash. So similar to what we did for the database names, that as you can see here are actually being changed, it's gonna be the same for the port. I'm gonna change the gateway to 302. The admin of the gateway is gonna speak with 302 and is gonna listen to 303. Notification service can go to 5, we don't care, and shipping service can go to 4. I'm gonna choose these numbers just because 4 I have some code already, so we will not waste time in seeing me typing. And that should be it. As this continue to install, I'm gonna create also another folder called fake client. And in here, we're gonna have our main JS, as we mentioned it. And eventually, we're gonna also have tracing JS. I'm just going a bit ahead of time just to have everything ready. Okay, so we run the npm install. I need to run the Prisma generate. So this is gonna generate all of the tools that I need. Okay, and now I'm gonna run a db init. So just to show you really quickly, I have my pg admin. I'm going to the localhost. I have these 2 databases only. I'm gonna just run that. And this is gonna run the migration, create a migration for every single service. I think I did forget to import entities. Yes, I did. Okay. 1 second, let me import entities for the notification service as well. Otherwise, yeah, here we go. I have 1 entity with message, title, and customer ID. Let's commit this. This will create a new pull request. And it's nice to see that is actually gonna work. Let's go back in here. Now let's quickly check if the database is all good. Refresh. Now we have a courier, a notification, and a shipping database with the right info. Let's check the tables. Yeah, courier, quote, and shipment. Fantastic. So now we want to connect the shipping service to the courier service. Before we do so, I'm gonna use, I need to start all of the services, of course. So I'm gonna open a few terminals. I'm gonna leave the notification for now because it's not that important for the initial bit. Okay, and the admin as well. Okay, so what I need to do, I want to collect some files randomly from the gateway service. So what I'm gonna do is, there we go, it started. I'm gonna log in the admin. As you can see, it's really simple. I'm gonna go to parcel, create a parcel of price £4, small, save. I'm gonna create another one of, I don't know, £23 for a medium size. And since in UK we had Brexit, everything costs much more, so I'm gonna go large for £48. Here we go. So we got the data in the database. I'm not gonna show you because that is actually in the database. We will see that in a moment. Let's dive into and connect the 2 services. So go in the shipping service. There is a little problem. I'm going to solve it straight away. And we have a tiny bug that we are going to solve it soon. Okay. I'm going to install Axios here to make a simple request. And what I want to do, I want to create a call to the courier getaway once the shipping is getting created. So I'm going to check the basic one. We have a create function. I'm going to get that one. I'm going to extend it. So I'm going to go in my service. Now, let's import everything that I need. I'm going to const shipment equal to that, await. And I'm going to call the underneath service. So super my public. And I'm going to use the right type. I did a mistake in a second. Oh yeah, I haven't imported it. Okay. Now, let's add a bit of useful code to make a call. I'm gonna just copy this one because it's no point for me to just write some Axios. Plus, I might do mistakes. Right? So first of all, we want to make a request to 302, that is our courier gateway service login API. How do I know that? I'm gonna check in here my nicely generated Swagger definition. And I want to call this one with this body. Of course, you don't want to hardcode the data, but in this case, we don't care. And then I'm gonna call the parcels, and I'm gonna collect one of them randomly. So let's make another call that is gonna leverage this authentication token to the parcels. And out of that, what I'm gonna do, I'm gonna collect a random parcel from this list. And what I'm gonna do, I'm gonna pass this one to the actual parcel. I want to set up the price with a random parcel price. Okay, that's it. Let me see if I'm missing anything. No, all good. So let's try to run this just to see that everything is working fine. Yeah. Okay. So let's make a request URL to the shipment creation. Okay, it's created. Good. So that means in here we got a request. Yeah. And in here we got a couple of requests. Login and parcel. Everything is tied up together. Fun. So now, before we move forwards with the application generated, and before we start instrumenting all of this, let's create a fake client. Fake client, as I said, we can do something really simple because we don't have the time. We do have the time for production-ready code with application, but not with this. So I'm going to create something like that. And I'm going to install Axios here as well. If I can type. Okay. And this is going to make a request to what the CRL that I used before, same thing, but it's going to make 5 requests out of this. Let's just test it for the sake of tranquility. Okay, we got 5 requests with random prices that we can see here, right? Random prices. Fantastic. Now, this is the time to add tracing. And we'll now finally into what we want to play with. So as I said, this is a brand new service. This one doesn't have anything. What you can do, you can start really simple, and you can just import what you need. But just for helping us with this instrumentation, I'm going to install all of the dependencies that we need for this new fake client. We will need the OpenTelemetry API, resources, semantic conventions, you will see why. An SDK for Node, because we're using Node.js, of course, and some instrumentation HTTP for auto instrumentation. Okay. And then once we have this dependency installed, I'm going to also create like a default startup, like a configuration for your tracing. Right? So I copied this one because, of course, it's quite a lot of code. I don't want to do it now. So what do we have? Do we have, if we go in order, things that we're gonna need, we have an SDK. That is, SDK start is what we want to see. And in this SDK, we define the resources through some semantic naming conventions. So we define my name, the name of this service that I'm going to trace, and also the version if I want to. Then I'm going to decide the span processor. This is the processor that we saw. I'm going to use a simple span processor that is going to process each span in isolation. And I'm going to use an exporter that is the default OpenTelemetry trace exporter HTTP version. Okay, by default, if I use this exporter, the URL is going to be this for HTTP and 7 for GRPC. So I don't need to add it. So I'll leave it just like that. Then instrumentation to have some auto instrumentation regarding any module in my application that use the HTTP module from Node.js underneath. And final, a propagator. This is a propagator is the trace ID, right? It's the trace ID we're gonna see. Propagator will allow Jagger to understand the trace across the services. Now we have all of that. Of course, it's not called by main, but we're gonna import it. So we're gonna go in main and we're gonna get the tracer. And be careful, it needs to be before any requirements for Axis or other libraries. Otherwise, you will not be able to wrap the HTTP module. Then we're gonna potentially get, let's say we wanna get the tracer. And here is how we're gonna see, how we're gonna trace a specific version size. Let's start this without anything, and let's just trace the generic top function. So I'm gonna copy it because it's a bit tedious to write. So I'm gonna have a main function. I'm gonna use the start active span, and I'm gonna call main. Then I'm gonna end the span, and that's pretty much it. Let's dive into it. Let's see if I didn't break anything. Okay. Systems are looking good. Let's have a look to the trace data. We're gonna have something that will block my view. All right, we are in Jagger now. This is Jagger attendees Jagger. We have a service, the fake client app that we just did. Let's find the traces. We only run one trace because we've wrapped the entire main execution that creates multiple requests at the top level, right? So let's go inside. We can see that we have 1, 2, 3, 4, 5 requests. And this is how everything is connected. Now, let's say that we want to be more specific. So the HTTP post here, those are they are recorded thanks to the OpenTelemetry HTTP instrumentation that we defined in here. Without this one, we will not get those. Easy to check. Just for the sake of science, run this. I'm gonna change it because I want that data. Go back. Not more info. Okay, let's add one more thing. I want to create a new spawn, okay, when my request is returned. So I can do it at this level, or I can do it at this level, it's up to me. I'll do it at this level. So I'm gonna return, make a request, and I'm gonna call it request ID, request ID. Then I'm going to do this, and I'm going to return the results. But before I return the results, what I need to do, remember always to do it, is to close the span. because otherwise the span will be open and the telemetry will not be satisfied. So in this case, this will automatically create a new span and open it and start it. Then you need to close it. So if you need to catch exception, remember always to close it at the end. Let's run it again. Let's go back in here, check the latest. Now we got another one. Here we go. We have main, we have request ID 0, 1, 2, 3, 4. And out of those, if we want to actually look into it, we don't care about all of them. You can see that, okay, to make the request here, there is a bit of overhead because of the code that we have, but that's pretty much it. Right? So I'm going to reduce the number of requests to 2 or 3. That doesn't really matter. Now, we don't see anything else, right? We don't see the application services, even though those are returning data fine, because we can see them here. Let's go in the shipping service, and let's now instrument like an application generated code. Right now, we don't have a plugin for it, but the plugin is on its way. But you will see how much effort will be to start it right now without that plugin. It's not much, so let's do it. We're gonna leverage this application OpenTelemetry SDK. We start maintaining an open source solution, and we actually improve it. Now we'll be able to trace a lot of common components of Nest.js framework. If you don't know what Next.js is a backend framework to create a Node.js application, and is highly MVC pattern focused. So it has controllers, it has injector, guards, GraphQL resolvers. Well, all of these, if you want, can be automatically traced by the tracing library that we just installed. Let's gonna add it. At this level, I'm gonna just copy it because there is quite a bit of code. Not too much. So here we go. Import it. And I'm also going to import, as we did for the simple one, the simple service, I'm going to create simple span. I'm going to just use GRPC right now, just because I want to make my life a bit harder. I use the default, and I give the name of the service. So if we don't define anything else, we're going to get what you see in the comment here. So we're going to get all of the auto instrumentation defined by that library. You go in that library, you see what the README will tell you. But it's pretty much using all of the auto instrumentation from Node. And it will also add automatic instrumentation for controllers, GraphQL resolvers, guards, event, and pipes. So I'm going to just remove this. Now we have this one. I'm not going to do anything else. I'm just going to try to start it and see if I didn't break anything. And likely enough, it will start successfully. Let's run again our request. Let's go back, check now. Oh, look at that. We now see that this is the trace overview. If I click in, I got my trace, and all of these spawns will be part of either the fake client app or the service app. So the post, again, those two are coming from the HP auto instrumentation. These middlewares are coming from the Express. There is another web server framework for Node.js auto instrumentation that Nest.js is leveraging. And then we do have the shipping controller that makes 2 requests. You see, the shipping is calling the service. It's going to make 2 HP requests, API login and parcel. We got a bit of how it works now. Let's do the same with the getaway service as well. I'm gonna install it as I did for the other service. And I'm gonna copy all of that and put it inside our service. Hopefully without making anything broken. Of course, I need to rename the service, otherwise it's career getaway service. And I'm going to start it now. right? One more time. And we're gonna see, we don't have much time, so we're probably gonna skip the Kafka one, but the concept is the same. I can actually leave in the repository the example with Kafka. Let's find some traces. Now we have the traces, and we also have the controller login, as we can see here from the Query Gateway service. So this will give us a nice system architecture diagram. Teeny tiny, but is there. We have fake clients up. They also only call the shipping service. Shipping service is called by this one and called the gateway. Imagine this one in a much bigger scale, much bigger scale, and you will see what the diagram was at the beginning of the presentation. That is actually how Uber created that diagram. You can compare different traces. And this is kind of useful when you have, like in this case, I want to compare this one with another one. That is going to be pretty cool, because you can see where the bottlenecks are hiding. And you can also see other information like a flame diagram, flame graph, that will tell you where the time has been spent, so you can focus on specifically what is the most timely consuming operation. You can add custom segments if you want to, like we will want to see in this case. We see that this is going to take X amount of time. We can use the libraries, or we can add other information. And this is the last thing that we're probably going to show today, instead of Kafka. So for Kafka, the only thing that you will probably need to do, as you might have understood now, you're going to pass instrumentations. And instrumentation will have a new, potentially Kafka JS instrumentation that I need to install. Is OpenTelemetry Kafka JS instrumentation. Yeah, really crazy name, huh? And inside here, you will have configuration to make it a bit more complex, right? But let's have a look how we can enhance the data that we have. Or actually, before we go there, we say that we can spot quite easily where the problem is coming from. Let's create a problem. I'm gonna go in the gateway service, parcel, controller. So we say that controller-based service is causing the find many, for example. I'm gonna replace the find many. I haven't tried this one before, so let's see if I can break the code. And I'm gonna do super. I'm gonna override my system, and I'm gonna bring this one in. And instead of returning many, I'm gonna do new error. It's me. All right. Rebuilding. Let's call this one now. I'm expecting a lot of errors. Here we go. Internal server error from the shipping service. Oh, now we need to investigate what the heck is here. Let's check the logs. Oh, it was not there. Check the, oh, it's this log. Oh, maybe this one. Ah. Yeah, we're not cavemen anymore. We can actually use data for it. So let's search for the information. Oh, look at that. The last trace showed me 4 errors. It showed me errors in the gateway, in the Query Gateway, and in the shipping service. Really cool. I can see straight away the shipping service create fails because something underneath fails. Oh, it's actually the courier service get parcels that is failing. Fantastic. So I know if I solve this problem, I will likely solve the other problems as well. Let's gonna check the logs. Oh, look at the logs. Fantastic. I can see the event name as well. I can also see if it is an error. And I can see the error status. And I can see the status code as well. And you can modify this information as you wish, right? So in this case, we have a status code, error. You can put more data if you want. Logs, of course. You can, in this way, you have logs in the same place where you have tracing. That is making your life so much easier, and you will be so much more productive in solving issues. Again, system architecture is not going to change, right? It's be the same. The other tools, like for example, X-ray, it will allow you to see, like from a service map, it will potentially show you like a bigger bubbles for services with errors. So it will be even easier without going through this one, right? Without even filtering out. But let's say that I don't care about service client. I only care about shipping service. So I'm going to check shipping service only. Oh, I don't see that because all of the traces the shipping service have right now, they're coming and starting from the fake client API. So if I do now a new request, like the initial request that we had at the beginning, the CURL, so bypassing the fake client, we're gonna see there is a new request just for the shipping service with no information about the other one because the other one will never be called, right? And in the other one, we don't have it, of course. Now, yeah, the last bit I was promoting, I haven't mentioned it, is how we add additional information. So we saw how to name a span at this level, I give a custom name, but let's give a bit more details. And let's be mindful. I'll do something really bad right now, and we're gonna discuss when we go back to the slides why that was so bad. So what I'm gonna do, I know that in this URL, what we can do results. Yeah, let's do results. I'm gonna do span dot add. We can add, yeah, we can add events. But what I want to actually, let's do something even better. I'm gonna change the HTTP instrumentation. So I'm gonna customize it. I'm gonna add a hook on the request, okay? And in this request, I can hook whatever I want. In this case, I have a span. So what I can do, I can set an attribute for the request, and the value, of course, the value will be attribute value. It's the request itself. But I just don't want to do the request. I want to do headers. Headers. And let's see if, oh, yes, 1 second, I forgot that. Let's see how that works. I forgot to undo my fantastic error generation. Give me 1 second. Parcel service. Let's do this one for now. Okay. Did it build already? Now it did. Okay, it came back to life. Search for that. All right, now if we go in the HTTP, we should be able to see additional data. Here we go. We have the HTTP methods, the status code. So we have all of this information that we potentially didn't have before. And you can do this one for everything, right? You can do it for Kafka, for example. You can do most of the auto instrumentation will allow you to do so. So now let's go back to the slide to wrap it up. So we saw some examples. Really, unfortunately, we didn't have enough time to dive in a bit more into it. I really wish to have touched Kafka instrumentation too, but you will see an example later on that is super easy anyway. So, but what are the gotchas from this, and what are the best practices? So, one of the best practices is obvious. Be sure that you are always passing the context across services. As we have seen, if something that is not instrumented and the context is not passed through headers, like in this case, you will not get the data. It will be split. Be security and privacy aware. Don't do what I've done. Don't add to the trace all of the headers of a request for HTTP, because that will contain authorization header, and that's a secret. You don't want to move the secret into a tracing observability tool or logs, right? Same for user data. Don't add attributes to a trace that is related to any personal identifier information. And think about balancing performance and data volume. As everything with logs, for example, too much is too much, right? Try to focus on just the interesting traces. Focus on what could be useful for your team. Let's say only trace specific user attributes for like subsection maybe. Filter out any noise. Don't trace health checks on containers. You don't need those. They are good for orchestrators, but they're not good for tracing data. It's always the same. And try to manage cost. How do you manage cost? High volume of telemetry data. If you are working with like a vendor, that could be a cloud, SaaS vendor, whatever, comes with a big bill. So try to keep the volume small. How you can do that? Well, you can do that using different sampling strategy. The two common ways to describe those are head sampling and tail sampling. The head sampling is a technique of sampling that makes a decision as early as possible. So a tracing and a trace data will be instrumented, will be stored and saved and processed at the earliest time. So let's say you can, for example, instrument at least one request per minute for each service, and keep after that 5% of the request. This will give you, like in this, for example, it will avoid having all of these massive amount of data that you don't need, have a bit of portion of what you want. But what is the cons of this approach? Sorry about that. Is the head sampling doesn't have the knowledge about errors that could happen later on, because neither high latency. This is where tail sampling is making that is part. Tail sampling is the opposite, is making decision where almost all the spawns have been recorded within the trace. This will actually have a really big benefit. You always sample traces that contains error, because you will never throw them out. Always be able to trace high latency traces, so you can actually detect bottleneck. And why this is not just the right solution and the only solution we should look at? Because tail samplers are often, are really difficult to implement, and often are just being left into the domain of the vendor-specific technology that you use. For example, AWS allow you to just retain a portion of the information if you want to, if you use specific samplers from AWS. And I think that's the three gotchas that I will leave you with it. Another one, actually, the last one about the sampling and processing. In the demo, we see that I was using simple spawn processor, but you can also use batch spawn processor, as we have seen in the OpenTelemetry collector. That will actually make your application run a bit faster. And yeah, that's time for Q&A. If there is any question. Can we add, so I can, let's start with the first question. I can see 3 questions has been asked during the time. So the first question, I guess, is related to the Amplication platform instead of like just telemetry. But if it is, to, I will answer with both. Can we add other message broker like AWS, SQS? Right now, Amplication doesn't provide a plugin for it, but due to the nature of the Amplication platform, a plugin can be implemented and can be done, right? Yeah, right. It's open source. If you're willing to try, or if you have a need, just let us know, or get your hands dirty, and we can support it, because we are supporting community plugins as well. In terms of OpenTelemetry, AWS SQS comes with, of course, is in the AWS ecosystem. They used to have X-Ray, so you will find a propagator for AWS. I might have an example of how you can propagate AWS, but this is a bit out of, let me show you. It's actually what we use. We don't use SQS, but you will see it in here in our library. We have a common configuration for tracing. So if you need some inspiration, just come and get it here in our library. We have a tracing module. So what we do, hopefully it's going to be visible enough. What we do, we have an AWS X-Ray configuration, and this will allow us to use SQS context propagation from the payload to use, like instead of Kafka, this one has message broker solution, fully traced end to end. I'm not going to answer the second question. And the last question, so I guess this one hopefully is answered. So let me know if you still have any question. And then we have another question from Ezegin. Yes, so she is, or he is asking, or she is asking, apologies, about the source code. If we gonna share the repository or something, yes, we will. This, I'm gonna put it in the chat right now, unless Sarah already did. Let me do it straight away. I'm gonna polish it because, of course, it's missing the notification Kafka, so we'll add it. But this will be the repository, and I'm gonna be sure that we will have also a clone or fork of this in our application repository, so you will never lose them. Yeah. Let me put it in the chat for everybody. And I guess I'll put it in the chat here as well. I guess there are not any other questions. Yes, we are good. So before I leave you going, a couple of resources. Of course, this slide you can screenshot if you want. Oops, I'm not sharing, sorry. This slide, here we go. You can screenshot if you want. Take a screenshot, those are the URLs, but we're gonna share them again in the webinar chat. And I'm gonna add all of these links into the repository. For any question, go to contact us, or regarding your application, of course, or our Discord. For OpenTelemetry, if you want to learn more about it, or application more about it, there are how-tos and demos. Like we can see there is a demo for OpenTelemetry that is completely vendor agnostic, using a multitude of different programming language. And it's really complete, but it's way too big to describe in this session, so it needs a bit more time. Or application to know how to use it. And with this, I guess I will terminate this workshop. I really hope you enjoyed it. If you have any feedback, feel free to send it to me, Daniele@amplication.com. If you like to see more about this, feel free to let us know. Even contact us, the team will be super happy to assist you, to follow whatever you actually want to see. And for any other questions that has been answered, in the meantime, I'll try to answer before I close the presentation. Thank you again. Have a good day, good night, whatever it is. Bye.